Okay, so let's try a real problem now. All right, so we're starting here with, so they want us to calculate the pH of the following points. They give us the molar concentration and volume of the acid, a strong acid, and they give us the molar concentration of a base, and then we're going to calculate the pH after we add certain amounts of base. So first point, before we add any NaOH, that's really easy, just we know what the concentration is. Of the strong acid, that equals the concentration of the hydronium, so we just have to negative log that concentration, figure out what the pH is. And then we're going to add 10 mils of base, then 20, then 20.2 mils. Now, when I go from 10 to 20, this means 10 mils from nothing, and then 20 mils from adding nothing. It's not that you're adding on to part 2. This is from the initial. This is 20.2 from your initial, which was 0. All right, so you'll see what I mean in a second. Let's see, so for part 1, we said that the molar concentration of HCl is 0.500. Since it's a strong acid, that also equals our hydronium concentration. So how do we find pH if we know the hydronium concentration? pH is just going to be negative log of 0.5. So go ahead and work that out. Negative log of 0.5 should be 0.3. 0.301. You can do 0.301 if you want. 0.30, 0.301, something like that. It's fine. So it's very acidic. It's what you expect. What you should expect. It's just a strong acid here. Now in part 2, we want to follow the steps that we had before, right? So let's go back over here to our steps so we can see what we're supposed to do. And it's okay. You can keep referring back to this until it becomes like second nature. So we want to find the moles of the acid and the moles of the base, and then we want to find the moles of the excess acid, take the difference, find the molar concentration of the acid divided by the total volume, and then we'll get the pH, negative log of that. So moles of acid, moles of base. Molar concentration times volume gives you moles. So what do they tell us here about our molar concentration and our volume? So moles of acid are not going to change throughout the whole problem, because we're talking about our initial moles of our acid. So let's find here moles of acid here. So I'll call that moles of A. That's our initial moles of A. I'm going to take the molarity of A, of the acid. That's the molarity, 0.5 molar. And multiply that by the volume. I'm going to put that volume in liters. So I had 20 milliliters, so that's 0.02 liters. All right. I think I need another O after here. All right, so work that out, and you should get 0.01 moles. 0.010 moles of acid. That's our strong acid. That's our HCl. Now, find moles of the base. Same way. Moles of base. Moles of base. Oh boy. There we go. The molar concentration of the base of the sodium hydroxide is also 0.5 molar. It doesn't have to be the same. In this case it is. And then in part 2, they're telling us you're adding 10 mils. So that's 0.0100 liters. All right, so when you work that calculation out, you get 0.005 moles. And that's of the sodium hydroxide. All right, so if you think about what's happening here, is you have hydrochloric acid. It's reacting with the sodium hydroxide. You're making sodium chloride, which is a neutral salt, right? It has a pH of 7, so it's not going to affect the pH, and some water, right? We just did a really easy double replacement reaction. If I'm starting over here, if I'm starting off with 0.01 moles of HCl and 0.005 moles of NaOH, which one am I going to use up completely? So this is a strong and a strong, they're really going to react. I'm going to use up all of the sodium hydroxide because I have less of it. Right? This is like a limiting reactant kind of problem. I'm going to use up all of this. I'm going to use up about half of this stuff. And I end up with 0.005 moles here. So what I did was basically, just like what we said we were going to do, I look at the moles of the acid and the moles of the base, and I subtract the moles of the acid from the moles of the base. And this is how many moles of acid I have left over. This is my moles of acid in excess. I have 0.05 moles of acid in excess. So I have 0.0050 moles of acid, of strong acid. Let's do moles of HCl. Now, if I want to find the pH, I need to find out how much hydronium I have. How much hydronium? It's the molar concentration of the hydronium. So I know that if for every 1 mole of HCl, this thing is going to break down into 1 mole of hydronium. So those are my moles, but I need the molar concentration. So you remember what molar concentration was? Molarity is moles over liters. So I want liters of the whole solution. I need the whole solution this time. So the volume of my solution, right, total volume. All right, so how do I find the total volume? I used how many liters of HCl? I had 0.02, I had 20 mils and 10 mils, so 0.02 liters of HCl, and then I used 0.01 liters of sodium hydroxide, so that's going to give me 0.030 liters total. So now I'm going to take these moles and I'm going to divide by the total volume, 0.030 liters, and that's going to give me the molar concentration of HCl, which is also equal to the molar concentration of the hydrofluoric acid. So when you work that out, you get, that's a 0.167 molar, and that's also going to equal the hydronium concentration. All right, and so after that, I can find the pH. pH is equal to negative log of 0.167. All right, when you work all that out, you should get a pH of like 0.77, something like that, 0.77. And that's your pH. So it just went up a very little bit. Right? The original pH was 0.301, and then the second one was 0.77. We're going to eventually plot this in a titration curve. We're going to plot pH versus volume. That's going to be the last thing we'll do, pH versus volume of NaOH. Let me just review these steps for a second. So the first thing we did is we calculated the moles of the acid, and then we calculated the moles of the base, right? And then we took the difference. Then we calculated the total volume, and then we did the molar concentration, and after that we found the pH. So there's basically 6 steps in there. So find the moles of acid, find the moles of base, take the difference, calculate the total volume, then divide by the total volume, then calculate the pH. And then that's how we got to the pH there. So if you follow those steps every single time, you'll be fine.